Vector calculus. Vector calculus, vector field. So, vector field is something that is a kind of cornerstone in the vector calculus. So, it can be considered as a gem or something like pioneer in vector calculus. So, we have two things that we have seen in the vector calculus. One is pure algebraic equation and other is parameterization of the vector where we push the algebraic equation inside the vector where the independent component is only one, that is t, and t is independent component for all the components of a vector. If it is a 3D vector, then x component is dependent upon t, y component is dependent upon t, and z component is dependent upon the t. So this is what we have seen as far as parameterization in the vector is concerned. So vector with algebra. So that is a kind of point that we have seen, a vector with algebra. So if I have x component of vector and it is a function over t, that is ft, gt and ht, then it is a kind of vector with a function over an independent component vector with algebra. So that is the scenario. But since vector cannot be kind of, if we see the vector, then it is a typically a position vector. If I have a point here, x, y, z, and if I say, can you specify the vector, then from origin, I draw a line to x, y, z, and then we will differentiate the subtract x to the beginning, that is x minus 0, y minus 0, z minus 0. In that case, this is called position vector, and that is xi plus yj plus zk. But situation comes when we want to kind of place an offset in the vector, that is displacement vector, but displacement vector in actual scenario is not possible in vector. Everything is position vector only. Okay, so like if I have a point 002 and if I shift this vector origin to 002 and other is, suppose other is 234 and I shift it up, that is 236, the new vector from 002 to 236, if I get the vector, then I have to subtract again. So it will come to 2i plus 3j plus 4k again. So 002 and 236. Same 2i plus 3j plus 4k. In order to get rid of this kind of limitations in vector, so the parameterization vector, what we have done with the independent function t, that we add the kind of vector where it starts from, that as the beginning vector. So it becomes like 0i plus 0j plus 2k plus 2ti plus 2t 3tj plus 4tk. If another vector is 2ti plus 3tj plus 4tk, then a vector that starts from 002 and ends at 236. Okay, earlier we had origin 0000234. I shifted this vector to 002 and 236. Then actual equation of the vector as far as parameterization of the vector is concerned, then it is 0i plus 0j plus 2k one side plus t, and inside the braces 2i plus 3j plus 4k. Now we have a full-fledged a vector which looks like an algebra. Okay, but still, now we'll see more in it. Vector field, magnetic field. I mean, vector field, something similar to like magnetic field. I have a magnet, and this is south pole, and this is north pole of a magnet. Two magnets, south pole, north pole. Like Earth, we have south pole and north pole. Now, if I now there are magnetic field from this south pole to north pole. If I want to draw the magnetic field, then I would take a compass, and compass I'll keep placing compass in the path, and whatever the path it is showing, I'll draw it, and that is the magnetic field. Similarly, if I take the compass, then south pole of the earth and north pole of the earth, then it will point in that direction. So I can draw the magnetic field. Okay, what is magnetic? I mean, I can have algebraic equation, right? So if I have algebraic, if I have algebraic equation, then with the kind of if algebraic equation is nothing but function over x and y, function over independent components. X, y are independent components, whereas in parameterized vector, x, y are dependent component on a new independent component t that is available everywhere. So x, y, and z component are all are dependent now on the independent component t, where in the algebraic equation the function over x and y in 2D, that is f x y. So I can have algebraic equation, and then if I put a kind of uh, okay, I can have algebraic equation in the sense, I mean x and y, in the sense I would rather say fx, not fxy, fx. So at any x, what would be the y? Okay, and then we draw a line, 2D, fx. So I have x, and if I keep the x, then there is a function over x, fx, that gives the y. So if I have a 2D plane, in 2D plane, if I go along the x-axis and I keep point of x, then I get the fx. If I get the fx, then if I draw the fx, I get the magnetic field line. So what is the problem? Okay, so if I have so many x point, against each x point I have y point, against each x point I have y point. If I have y point, then these are set of points, I can connect it, but these are set of points. If I connect it, there is no direction. Okay, so the biggest issue here is that there is no direction. If there is no direction, then it cannot be a magnetic field. If I have a function over x fx, and each point in the function fx, then points in the fx, against each x I have fx, then the point, what we get, we have separate value of x along x-axis. For each x I have y, then y are nothing but set of points. Now if I connect the set of points, it would give me a line, it would give me a curve as per the equation fx. If I connect, but there is no direction, and it is set of point, not set of direction. If I want at each point, whatever point we are taking, so now the point is kind of x comma y. Earlier the point is x1, and then we have y according to the point. Now I have point as x comma y. If I have point x comma y, then at each x comma y I should get a vector. That is actual magnetic field. So if I have a south pole, if I have a south pole, and if I have a north pole, and then at each point, if I see the magnetic field, it should show a direction at each point. Okay, so suppose this is south pole and this is north pole, then if I draw magnetic field, it will go straight. But if it's south pole, if it's north pole, if I take this direction, okay, then at each point there will be a vector. It won't be straight. how it will be straight? If it is south pole and it is not north pole, then if I take compass like this location, then the needle of the compass, if I consider the needle of the compass as vector, then at each location the direction will be, so at least here if I draw, then if it is really a magnetic field here and here, some vector it would show. Okay, something like this. So at each point, now rather than connecting each point which won't give anything to us, at each point, whatever the needle direction is, okay, whatever, if I go straight, the needle direction will be straight. But if I go in some curve fashion, the needle direction will be somewhere, something like this. So at each point, if I see the needle direction, then that is the actual magnetic field. At that point, if I have x comma y, if this is xy plane, if this is xy plane, if this is xy plane and this is north pole of a magnet, this is south pole of a magnet, then if I take the compass from here in this direction, then compass needle will be straight. But if I take the compass somewhere in the curve, then needle would rotate as per the magnetic field whatever it is saying. So at each point, what is the direction of the that needle, okay, inside the compass? So it proves that I need a function over x comma y. If earlier we had x and function over x was a point, now I have x comma y. At any point x comma y, what would be the vector? 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 So I need a function over a coordinate x comma y. That function would produce a vector. This is vector field. So like magnetic field, if I want to draw at any point, if I start taking curve and then draw the magnetic field, needle would rotate. If needle rotates at each point, needle is a vector. I cannot just connect the wherever I am taking the compass and I keep connecting the line. It doesn't make any sense now. So at each point, if there is north pole, and if we are going in a curve, then at each point, the needle of the compass is a vector. If that is true, then I need a function where the input, the parameter of the function is x comma y, function over x comma y. In algebra, function over x comma y results in an algebraic equation where in vector field, function over x comma y results in a vector field. That is difference between algebraic equation and vector field. Algebraic equation is a function over x comma y, but it produces a, okay, so if I see in algebraic equation, the function over x comma y is nothing but it's a algebraic equation where here function over x comma y is nothing but it's a vector. So at each point x comma y, I have a vector, where in algebra at each point x comma y, it will come to a algebraic equation and it will solve it and it will give you one value. So that is 3D. So if I have kind of if I have xy plane, if I have xy plane, then at each xy, at each point xy, it will go in an algebraic equation. It will produce a value that is the z value. So at each x comma y, what is the z value? If I connect all the z value, it would result in a surface. Altogether, it will result in a volume. Like that, at each x comma y point, if I place in a vector field, it will result in vector at that point in 2D only. If it is x comma y in 2D only, it would result in a vector rather than coming with a value means a function over x comma y result in an algebraic equation where if I put an actual value scalar value of x comma y, it results in a value that is z coordinate. That is what we generally would say. But here fxy results in a vector. So why I am putting emphasis is that vector is one of the kind of thing that would finally generate the parametric vector. So sometimes we have kind of everything in a form of algebraic equation only. So from algebraic equation how we can come to vector field and then we'll come to parametric vector. So parametric vector is the nature of the calculus vector. I would rather say calculus vector. So everything, every technology, if you see, it has a base. Every technology, if you see, then it has a base on top of which technology sits. So if I get confusion, then we come down till we reach a concrete base on which the technology is sitting. Okay, like if I see the 3G internet technology or 2G internet technology, probably 3G would be sitting on 2G technology only. Something else it has been done. But if you see 4G LTE, then it is not sitting on top of 3G. It is altogether different technology based upon different base at all. So the calculus vector or vector calculus has its base where one independent component is there, that is t, and based upon that x, y, z component of vector exists. Whereas in algebra we have independent component as x, y, z, and based upon that independent component, okay, the fxy, that is a dependent component exists. That is the algebraic equation. That is the nature of algebraic calculus. That is the nature of vector calculus. Now we will see that how we can create a bridge between vector calculus and algebraic calculus as far as vector field is concerned. That is another kind of aspect of the vector field. But one aspect we saw that if we see the magnetic field, then at each point we have the needle pointing into different direction, and we need to have a function where function is function over x comma y, and for function returns the vector, that is vector field. So vector field will be like, if I say I have a vector field that is f, f is not small, f is capital function, but it is capital because you are vector field. So capital F and in braces x comma y. Or if I say x comma y is a position vector, then capital F in braces R. Okay. If that is the case, then F is a vector field, then F on top of it I can draw one arrow. Capital F on top of which I can draw an arrow. Inside that we have position vector R. Okay. So Fr or Fx comma y comma z equal to something xi plus something I plus something j plus something k, because after all it's a function over x comma y. We are not placing the coordinate. So f r, the vector field over x comma y comma z, or f x y z, whatever, capital F, and on top of it there is a vector. If that is the case, suppose that fr or fxy equal to xi, function over, now function is a vector. Earlier if I say that fxy equal to x square plus y, fxy, if I take any x and y, then the function is algebraic equation, that is x square plus y. If that is the case, then any x square, any x value and y value I would take, and it would result in a value, and that is a scalar, that is the vertical z. So z equal to fxy equal to x square plus y. But here the fxy, capital F, fxy would result in a vector. So I say fxy equal to xi. x I. Okay, now any point, okay, if I see in xy, I mean fxy, we have xy plane, not fx. Fxy is equal to only xi. Okay, fxy is only xi. So if this is xy plane, if this is xy plane, any xy I take, xy is 1 comma 2, this is x-axis, this is y-axis, then fxy 1 and y2 comes here, fxy equal to xi only, means 1i. So 1i means in direction of x-axis and its magnitude is 1 xi. So the vector at this point, every point in xy plane would result in a vector. So if point is 1 comma 2, then vector is xi, that is 1i. So in this direction, where magnitude of the vector is 1. If I say the point is 3 0, that is along x-axis. So at 3, here the vector will have direction like this, but okay, where the bottom of the vector, the base of the vector will be at 3. Okay, so if I say 3i xi, fxy is xi, then when x is 3, then it is 3. The vector which will have bottom at 3, this is 3.0, then vector will be in this direction. This is 3.0, then vector will be in this direction, where the power of the vector, the magnitude of the vector is 3. Okay, what about y-axis? Well, if I take any point on y-axis, then the vector is, if I take 0, 4, then it comes here. Then the x component, xi is the vector field. So x component is 0. It would be point or nothing. So along y-axis, there won't be anything, whereas along x-axis, the vector will be there along the x direction, where the bottom of the vector is where we have put the xi. And then the power magnitude of the vector would be that x. Suppose that I have a kind of a vector field. Equation is xj, xj. So if I say xj and then if I calculate at point that is 3.0, then vector will be in vertical direction because it is xj. Ith component is 0, but ith component is 0 and y component is there, but the magnitude is x, not the y. So fxy equal to xj. If it is 3.0, if it is, this is x-axis, 3.0, bottom will be here, and magnitude of 3, this is the vector. Okay, along the y-axis, again it will be 0 because x is 0. So if I take a point 3, 4, then it will be in vertical direction because xj. So at 3, 4, at this point, vector will be in y direction and the strength of the vector is 3. Okay, so this is vector field. Vector field means I have a function over x comma y. At each x comma y, at each x comma y, I need a function which would produce a vector. Okay, this is vector field. What can be example of vector field? Like velocity field, velocity field. Like if I can see in river or river or ocean or somewhere where I see the flow of water, okay, that is a vector field. Sometimes we see the round also, okay, whirlpool, okay. In that case, then vector field will be like this, then like this, then like this. Okay, if water is round, then vector will be like this, then like this, then like this, then like this, like this, then like this. Okay, if water is going like this direction, then vector field will be like this. So at each point, vector field would be different, because if river is flowing in xy plane, then at each x and y, what would be the kind of the direction of the velocity? That is the velocity field or force field. Like my Earth has a gravitational force; it pulls. So, if if I can say, then that kind of this is a kind of this is Earth. If this is Earth, then a particle is placed here, particle is placed there, particle is placed there. Then here force field is like this, force field is like this, force field is like this, force field is like this. Now depends upon where the force is maximum, where the force is minimum. So the force will be maximum when it is near and minimum when we go far. So force field, if particularly if this is Earth, if this is Earth, if this is Earth, then if any particle is here, then force field will be like this. If particle is here, then force field will be like this. If particle is here, then force field will be like this. So this is concept of the vector field. Vector field can be anything: magnetic field, velocity field, force field, like this. Okay. Now consider that kind of I have a velocity field. Consider that I have a velocity field. Then can I get back the line equation? The line equation. Okay. Means if I had a line equation, if I had a distance vector, then if I had a distance equation, then through the distance equation I had generated vector field. Consider it this way. I have a distance algebraic function. If I differentiate it, it gives me a velocity vector. How it gives me, that we'll see. If I have a velocity vector, then from that can I get back the distance vector? From velocity vector to distance vector. If I had distance algebraic equation, from that I received velocity vector. From velocity vector, if I have, can I get back the distance vector or line vector? Okay, probably I think this is too much now. So kind of we will see kind of more in how we get the vector field from algebraic equation. If I have an algebraic equation, then what is the relationship between algebraic equation and vector field? Algebraic equation, vector field, parametric vector, calculus vector, three things: algebraic equation, vector field, and parametric equation, parametric vector. So from algebraic equation, how we get the vector field? Because vector field is a function over x, y, z. So from algebraic equation, how we get vector field, and from vector field, how we get the displacement vector or line vector. Okay, algebraic equation to vector field to the the calculus vector or parametric vector or line vector. How we get back? So line vector, from algebraic equation, how we get the line vector? So vector field can be one of the media. So conversion of whatever the equation we already have in algebra, how exactly that will be molded into the parametric vector. So we can first create the vector field, and through vector field we get back the algebraic calculus parametric vector upon which we apply the calculus. So this can be one way where vector field can come as mediator. So this explanation is not available in any of the book. You go and search any of the book, people maximum they will tell you that magnetic field and each point, then needle will be there. It's not there anywhere. So whatever we are talking, everything is new explanation. So now from algebraic equation to coming to the parametric vector, through the vector field, that is not available anywhere. Okay, people will give you some formula that you have to apply, and then you come to some value. That's it. But what is the fundamental behind it? If you understand fundamental behind it, then only you can apply in the real life scenario. Otherwise, you cannot apply in the real life scenario. Maximum, you can get some marks in the examination, but it is worth zero, because at the end you have to come in your real life where the technology would help you. So technology would help you in your real life only when you map the mathematics to the real life. So that is one area like where the algebraic equation can be mapped to the parametric vector through the vector field. So this also will see, then we will see kind of gradients, partial gradients, that also we will see. And what is the similarity between vector and algebraic equation as far as derivative or differentiation is concerned. So those internal points that we will take out, so that conversion of the algebraic equation to the parametric vector would be easy. Once we come to parametric vector, then life is in the sense that that technology that comes as calculus vector, vector calculus, then whole and soul that we can apply. So that we will see.